This project, we're really talking about the Internet of Things, the data-driven farming, mostly around irrigation, and how to try to work with our ag producers and make their irrigation systems as efficient as possible. Put the right amount of water on at the right time so that that farmer has the maximum yields that we can get out of the particular system.
I think we as irrigators have a responsibility to go here, and guys my age, we look at, say, oh, we're, heck with it. I can look at that spot there and tell you when I got to water, and I'm going to water, and I don't care beyond that. But we have a responsibility to the fish people, to water, to managing things. We need to get there, and I don't know how we communicate that with the people that need to help us get there, because farmers are not going to do it on their own. They've got to be helped somehow. We don't spend money we don't have to spend. That isn't going to make a big difference. But this is huge. Politically, it's huge. It's the right thing to do, and I know it. I know it's helping the quality of the crop, and it's saving us. It's saving us power costs. It's saving us water costs if we have to buy water. And it's making a difference out there.
The goal is to help them with water savings, with energy savings, and help them make a crop that has the highest of yields and is the best quality. At the end of the day, we want to try to keep the farmers in business. And how do we do that? How do we use technology that allows us to see what's going on in the field and then use that data to be better farmers? And so with this project, it's called Advanced Precision Irrigation 2.0. And we've got remote sensors throughout the field. We're sensing pressures throughout the irrigation system. We're taking a look at the soil moisture. We've got some controls on the pivot irrigation systems. And one of the differences about this project is we're monitoring the pumping station. And so we're taking a look at how much energy is that pump using, how many gallons per minute of flow, and really trying to not only optimize the irrigation system in the field with the sprinklers and the main lines and the flows, but also going back to the pumping station and really trying to optimize the use of that pump. Is it all about cost, or is it about seeing the benefits, or just new technology?
I think probably the younger farmers probably think more about the right thing to do, and the environmental part of it more than people my age. And I'm just kind of how we are. We're kind of at the end of our run and not the beginning. But I've always tried to be proactive in doing stuff. And I think it's exciting to learn new stuff. And it's always expensive to do that. But and I think we have to tell our story. In ag, we've got to. If we don't want to, they're pressuring our water all the time, and if we're not being good stewards of it, we're going to earn the right to lose it just because we're not being good stewards. So I think we have an obligation, because of the times and because of the mindset of society, that we have to do that. It's just like when we went to bottom plowing, or from bottom plowing to no-till. The NRCS was very, very, very good about cost sharing some practices and getting us in, and now this whole county is in no-till. So it's the same thing with this stuff. We've got to be proactive, I think, in defense of our own industry and the use of our waters. I think we've got to be good stewards of it, because even being good stewards, they want to take our water away from us. They just do, especially out of the creek, and it's going to get to be a real challenge. And without this water, this land devalues to where it's priced like that land up there, where you can't irrigate it. You're devaluing your property, at least half. So we have a responsibility to ourselves and to our kids, and down the road, we've got to be proactive in doing all these things.
If a farmer was interested in taking a look at the technology, the first thing we should do is take a look at their particular site, where they're, take a look at their site and look at what their challenges are, so that we can help develop a package that would fit them best. Each field, each irrigation system is going to have its own challenges. It may be increased electric energy cost, it may be shortage of water, maybe a well that's not producing like it used to be. And so kind of taking a look at each particular farm so we can help put a package of equipment together that would work for them. And then the other piece of it would be is looking for different potential cost share opportunities. And that's a lot of the work that we do too, is there a way that we can get some assistance for covering some of the cost. At the end of the day, it's trying to help that farmer be as efficient as possible. It's taking a look at, is there opportunities for us to use less water? Are there opportunities to reduce the energy usage? But the first priority is, trying to keep that farmer in business, and then also trying to make them as efficient as possible.
That evaporation issue is huge. This fall, when we were just finishing cutting up there, it had stressed the ground out just a little, the hay out, and it was at least what Robert said, a 30% decrease in moisture available there, or maybe half or whatever. It showed that in the yield, like you could physically see that just by the evaporation issue, for sure. Yeah, so it's a pretty big deal. With Robert's help, I was able to read those monitors and see what was going on with the moisture, and you could make decisions, particularly when you get up close to cutting. We got into that between second and third. So to me, I said, well, maybe I better run over it again. We got 2 weeks to cut and another week to get it dried. And Robert looked it up, so now you're still at 70% capacity in the soil, and so that's enough to carry you all the way through. So I think I elected, instead of going a 24-hour set, and I'm talking about over on the wheel lines, I elected to go a 12-hour set rather than 24 because of that. So that, the data was really helpful.
So the software incorporates all available data. So we'll bring in real-time weather data. Now, think what you can do with that. You have wind, you have humidity, you have temperature. And all of those have a negative effect on application efficiency. So if you're throwing water out under the pivot, or even worse, from a wheel line, the more you throw the water into the air, the more it will evaporate. But these elements, humidity, temperature, wind, has a detrimental effect. Now we can calculate the effect. And we can actually use the weather forecast looking into the coming week and say, today it's quiet, it's not too hot, this is a good time. Our application efficiency in terms of how much water are we getting into the ground is high. But maybe tomorrow, when it's going to be 100 degrees out there with a 30-mile-an-hour wind and the humidity in the teens, if you use the same system, your efficiency might drop from 70 to 50. So if you know that and you don't have to irrigate, you can just park the equipment and you've saved yourself 20% of that water. Again, just from knowing what's coming. And that's one of the benefits of having real-time weather, analyzing it, creating a projection.
With the technology, what we can do is actually help put the right amount of water on at the right time to maximize the yields for the farmer. So many cases, the farmer may be under irrigating at one point, the crop goes into a drought mode, and then they pour the water on to try to make up. So they're under irrigating here, and then they've way over irrigated, and they've exceeded the amount of water that the root zone can hold. And with what we're trying to accomplish here with the data-driven agriculture is we're really trying to fine-tune the operation, put the right amount of water on at the right time so that farmer has the maximum yields that we can get out of the particular system.